in this question, uh, fork and join construct is given and we have to identify the respective precedence graph. In fork and join construct, fork L means it starts parallel execution at the statement labeled L and the statement following the fork. For example, here fork L1 means it starts parallel execution labeled at L1. Here L1 is labeled at, here this is L1 and here S3 is there. That means S3 labeled L1, S3 is there and S3 and the statement following L1, S2. That means S2 and S3 will start parallel execution after S1. So if we see the options here, all the given options contains S2 and S3 parallel after S1. And join count means it will recombine the count number of concurrent computations. Here count is declared as 4. That means join count will combine 4 concurrent computations. If you see options, here also 4 concurrent computations are recombined. Here in this option also 4, in option C also 4. See, after fork L1, S2 and S4 will be executed. S2 and at L1 S3 will start execution parallelly. That means S2 and S3, and after S2 S4 should be there. After S2 here also S4, here also S4. After S2 here in this option B, after S2 S4 and S5 start parallel execution. But if you see this fork and join construct, here that is not the case. So we can eliminate option B. If you see option C, S2 and S4, after S4 fork L2, that means L2, after L2 8 is there. That means S7 and S8 will start executing parallelly after S4. So this if you see option C, same is the case. After S4 S7 and S8 starts execution parallelly. So after L3, after fork L3, after S3, L1 S3, fork L3 is there. So at label L3 S6, that means this S5 and S6 will start executing parallelly. So S5 and S6. So if you see options, S5 and S6 are executing parallelly. So if we see after S7, go to L4, label 4. At label 4, we are joining the parallel executions. At S7, after S7, after S8, also go to label 4, and after S5, also there is go to label 4, and after S6 also. Here we need not mention go to L4. Why? Because after S6 it is L4. That's why we need not mention here. So here with this fork and join construct, we can say C is the equivalent precedence graph.
CPU has made the following string of references. The references are 1, 2, 3, 4, 2, 1, 5, 6, 2, 1, 2, 3, 7, 6, 3, 21236. So these are the references that are made by the CPU. Which one of the following is /r the number of free frames which resulted in the same number of page faults for all the FIFO, LRU and optimal page replacement? Assume that it uses pure demand paging. Pure demand paging means initially there were no pages in the memory. That is, all are empty. Normally if you take one free frame, it makes no difference among the number of faults whatever the algorithm use, because the selection of page to be replaced is only one. There is no competition. So whatever the algorithm use, you will get the same number of page faults, whether it is FIFO or LRU or something optimal page replacement. So option A is one thing, and again let us more frames also will see. If you take 2 frames, so definitely there will be a change in the number of page faults. For example, FIFO, if you take for the 2 frames, so 1, 1, 2, again 3, 2, again 3, 4, again page 2, 2, 4, again 2, 1, again 5, 5, 1, again 6, 5, 6, again 2, 2, 6, again 1, 2, 1, again 2, there is no fault. 3, we have to replace 2, 3, 1, 7, we have to replace 1, 3, 7, FIFO, again 6, we have to replace 3, 6, 7, again 3, we have to replace 7, 6, 3, again 2, 2, 3, again 1, 2, 1, again 2, no fault. 3, 3, 1, 6, 3, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18 faults have come. If you use LRU, it may be different. For example, 2 frames, 1, 1, 2. For 3, we have to replace 1 because it is the least recently used. 3, 2, 4. We have to take among 3 and 2, 2 is least recently. 3, 4, again 2, 3 we have to replace, again 1, 4 we have to replace, again 5, 2 we have to replace, again 6, 6 we have to 1 we have to replace, least recently used, again 2, 5 we have to replace, something like this. So now even for optimal, so here if you take the algorithm of all these 3, we can have something. For a FIFO you may get 7 faults. If you take number of free frames 7, for LRU you will get 7 faults. For optimal also you will get 7 faults. For all these things 7 faults are there. So for 7 free frames and first free frame, so we will have the same number of page faults for all the algorithms. So